Hello students, today we're going to do chapter 7, 2 notes, the first part of it. Types of reactions. There are actually 5 types of reactions that we're going to go through, and the first one is synthesis. Synthesis is a type of a reaction in which 2 or more reactants combine into one product. The generic form is A plus B yields AB. An example would be Li plus oxygen yields Li2O. Notice in both of those there's only one product. So there's only one product. Another example would be H2 plus O2 yields H2O, one product again. Or a different kind of example, kind of idea of what's going on is a skinny bird eats a worm and then it becomes a fat bird and you get one product from the 2 combining. The next type of reaction is decomposition reaction, which is a reaction in which one reactant breaks down into 2 or more products. So it's the opposite of synthesis. So the generic form is AB goes into A plus B. So you've got one reactant. Or NaCl breaks down into Na plus Cl2. Another example would be the water breaking down into hydrogen plus oxygen. Or a different type of example would be an egg that breaks down. So an egg that has a turtle in it breaks down into just the egg, the shell, plus the turtle. The third type of reaction is single replacement. Single replacement is a reaction in which one element replaces another element. The general form is AB plus C yields AC plus B. Now this C, depending on what it is going to replace one of those. So in this example, since we've got oxygen, which is a nonmetal, it's going to replace the F, which is a nonmetal. So LiF plus oxygen yields Li2O plus F2. Or a different example, we've got zinc, which is a metal. It actually replaces the hydrogen. Even though hydrogen is a nonmetal, hydrogen is positively charged, and so it replaces the other positive one. Or in this example, we've got cool guy plus a couple, and then the cool guy switches out with the other guy, and then the guy in the white shirt becomes by himself. Here's another example. Sodium is the metal, so it's going to switch places with potassium, which is the metal. And so the sodium bumps out the potassium. Here's another one. This time we've got fluorine, which is a nonmetal, so it's going to switch places with chlorine, which is the nonmetal. So those bump each other out. The next one is a double replacement reaction. That's a reaction in which 2 compounds switch positive ions. So the AB plus the CD, remember the positive ions are always written first, and so those 2 switch places. So in our example, our PB, which is positive, lead, switch places with the K. So now we've got PB and I together and K and NO3 together. Another example would be your Ag switching places with your sodium. Or in this one, we've got Beardy with black hat plus non-Beardy with white hat, and then they switch hats. So Beardy gets white hat, the non-Beardy gets the black hat. Another example, in this one, we've got sodium and iron switching places. So the sodium's going to kick out and combine with the chlorine that was with the Fe. So you need to be able to identify the types of reactions. So make sure you do know those. The last type of reaction is probably the easiest, I think, to identify, and that's combustion. Combustion is a reaction in which an element or compound reacts with oxygen. It sometimes can be a type of synthesis reaction. The general form is A plus oxygen yields AO, but I'm going to teach you a little bit something else, and I'll show you that on the next slide. So in this, because that A can be anything, and so that's a little bit confusing, but it always is combining with oxygen. And this happens a lot where you have some type of hydrocarbon. CH4 is a hydrocarbon. plus oxygen, and then it creates carbon dioxide plus water. So here's how to recognize which type. Remember, E is for element and C is for compound. So first you should look at the products. Remember, products are to the right of the arrow. If you see just one compound and nothing else, it's going to be synthesis. Then you want to look at the reactants. If you see just one compound and nothing else, it's decomposition. If you see an element plus a compound, it's single replacement. If you see a compound plus a compound, it's double replacement. And then if you see an element plus a compound, but the element is oxygen, it's going to be combustion. So we're going to go through each of these, and I'll explain how to determine what it is. So first, you always want to look what we said. We said look at the products. So first you look at the products, and for the products I see a compound and an element. Remember, if you have more than one capital letters, it's a compound. If you have only one capital letter, it's an element. So it cannot be synthesis because synthesis is supposed to be one compound and nothing else. So then you want to look at the reactants. Second step, to look at the reactants. You look at the reactants and I see a compound and I see an element. So you've got compound plus an element. Both of these have compounds plus elements, but this one, element has to be oxygen. Our element is not oxygen, it's copper, so that means it's single replacement. We're going to simplify single replacement, abbreviated as SR. Okay, we are going to do the next one. The next one, you always look at the products first. You've got a compound plus an element. Then you want to look on the left-hand side. And the left-hand side, since this can't be synthesis, you want to look at the left-hand side, and we've got a compound plus an element again. This element is not oxygen, so here we've got single replacement again. Now let's look on the next one. The next one, we've got compound and compound. So on the products, we've got compound and compound. So it cannot be synthesis, so we look at the reactants, and we've got compound plus element. Remember, 2 capital letters is a compound, 1 capital letter is an element. So we've got compound plus element. So it can be one of those two again. This time our element is oxygen. So that means it is this. So that is combustion. So we're going to abbreviate combustion C. You should try and do the next two by yourself. Okay, look at the products. The first, we've got only one compound. If we have only one compound on the products, that means it's synthesis. So this is synthesis, we'll abbreviate that S. And our last one, we've got on the right-hand side, we have an element plus an element. So it can't be synthesis because it's not one compound. So we look at the reactants, and we've got one compound. Looking at this, if you have just one compound, it is decomposition. We'll abbreviate that D. We did not show an example. I did not have an example of double replacement on here, but you can look back in the notes and see the examples.